that we can share it with them. Yeah. And let me know once my screen is visible.
Yes, I can see your Docker PowerPoint.
Okay, great. So, hey Smita, and how are you, by the way? And how are you, Shreya?
Sorry?
I'm asking that how are you right now? I am just
Oh, I'm doing good, Bipin, but I'm facing some difficulty in Docker commands. Like when I tried to work on the assignment, there were certain places where I got stuck.
Mhm.
Some I was able to resolve, but towards the end, like I sent you the screenshot,
Yeah,
it didn't work. And so I would like to know your feedback as to how I can get over these hurdles.
yeah, absolutely. So that's what I will like to share it in between as well.
Okay. And
Yeah.
also another one of my issues was like if you're deploying multiple containers when you're writing your YAMLs file, your compose YAML script,
Mhm.
what parameters should I give apart from like once I have the image, once I've decided upon the image, now how do I know which ones I'll have to give volumes, which one I'll have to give environmental values, you know are
Yeah,
you understanding what I'm trying to say?
yeah, absolutely.
Yeah.
So that,
So
yeah.
that is something that is really kind of confused me.
Okay, no problem. So, as I said, whenever we play around with deploying the container, we usually has some sort of task on that. Let's say we want to have some execution of our projects, and we want to deploy our projects. So in that case, we usually know what all sort of things are required for executing these such projects. So what are the volumes and which database should be shared between them. So that's why I've taken that as a predefined values. Like we want to share the database container with the WordPress container, or you can say Drupal container. So in that
Mm-hmm.
case only, that's why I've taken that volume mounting as well. So because I want to share the data between each other.
Okay.
Yeah, and in your case, if you, as you said, what variable should be considered to deploy your multiple container. So that is up to you as per your application deployment, or let's say you wanna deploy your container individually, and you don't want to make some connection in the form of database connectivity. So that you can do. You can easily spin up, or you can say you can write some sort of YAML script, and based on that, you can spin up multiple container individual, or you can say they were independent of with each other. So
Oh, okay.
yeah.
Okay.
So
So far, I was under the assumption that multiple containers but connected to each other.
no,
Not
that is one.
necessarily.
Yeah,
Okay.
not necessarily. That is one example you can say,
Okay.
but that is a most of the usage where we exactly use this Docker Compose. And
Mhm.
meanwhile, we usually write this script in the form of YAML because why to spin up, or you can say why to hit a command for spinning up the container every time. So for that case, we usually write some sort of scripts, and based on that script, and you can use those scripts for the future times as well. So that's why we write all those YAML file and YAML scripts. So you don't need to hit the Docker commands every time in the Docker client dashboard.
Okay.
Yeah,
Okay.
in the corporates, they usually build up these such scripts, and they usually try to use these scripts as per their needs. They
Oh,
don't
okay.
pull up their images, and they don't pull individual images to container by using some command line interfaces. They
Okay.
usually directly pull up their YAML file scripts, and based on that, they directly try to deploy those.
Mm-hmm, mm-hmm. Okay,
Yeah.
now I get it. So these are all done once in, a long time, and then it keeps on being reused for so many applications.
Exactly, exactly. So this
Mm-hmm.
is how we are moving further with having some advanced feature to it. So we have started from
Okay.
the scratch level, spinning up the individual container, attaching with some Docker images as well. So
Okay.
yeah, moving further, we are leveling up ourselves with the help of using some Docker tools like Docker Compose. And now in today's session as well, we're gonna take up some more advanced feature of the Docker as well.
Okay.
Yeah. So, as you said, your queries will get into it as well. So, we'll check what all sort of queries and you have faced while completing your task.
Maybe towards the end of the class we can have like a 15-20 minutes on queries, what issues we faced with our tasks and things like that. If we can set apart some time just for that, that will be great.
Yeah, sure, sure, sure. We'll do it accordingly. That way will be the good thing. Yeah. So, after the end of the session, we'll have some
Sure.
15 minutes of
Yeah.
time to bust up with the assignments. Yeah. So, the rest of guys are there with me. Hey, Cholu. Good morning.
Good morning, sir.
Hi, how are you doing?
I'm doing good, thank you.
Good, great. So, as I said, we're gonna start up with our one of the advanced feature, which is leveling up our existing Docker environments. So now, so you might have. Let me check that, guys. Is my screen visible now?
No, I can't see it now.
Okay, I think I'm just off that. One sec. Okay, now it is visible.
Yeah, now I can see a Docker PowerPoint screen.
Okay, great. So, moving further, so let me take up with today's session, which is we're gonna take up some advanced Docker tools. So in the coming session, we'll brief you about that tool as well. What that tool will help us to around with this. So as I said, we have some. We usually try to build some images into our local machine, and or you can say we have came across with pulling the images into our local machine, and similarly we have tried to deploy those images to to a certain containers, and later on we have managed to deploy those containers, and we have managed to uh, attach some volumes in it. So you might have came across like there should be a question arises in your mind that what if your machines get, you can say, get failure due to some any network issue, or you can say by your machine got powered off and your applications got damaged due to that, because your host machine is running, or you can say it is taking the full load of running those containers, and by end of the time you can see that your host machine is got stopped by power failure or any of these such. So you should have some backup regarding that. So who can fulfill this requirement, like your host machine should, whenever your host machine get some issue, like in the form of power failure, or there is some hardware issue with it, so how to resolve those, and your container should be up and running all the time. So there should be some advanced feature, like your application is deployed into your containers, and you don't want to get stopped, or can say get some hurdle between those execution of those containers. So there should be one tool that fulfill these such requirements. So you can say the host machine is a single point of failure. You can say by for the Docker containers. Yes, guys.
Yeah.
So how there should be any tools which help us to which should help us to, like your host machine get some failure into your any kind of failure methods, like power failure or any such. So there should be some backup tools which help us to run our, you can say, make our container to be executable in the background as well. So moving further, so well today we're gonna discuss that tool as well. So there are some certain questions, like how to automate your life cycle, and in the form of like your container, when your container should start, and what all sort of command should be executed in this, and how should your container get stopped, and when your container should get stopped. So there should be a initial and the final stage of life cycle of your containers. So then and then only you will get some proper outcome from that. So you should be there should be some research question, and how we can fulfill those requirements. So that will be considered in this tool. We call it as Swarm. So that will discuss in the coming slide as well. So how you can easily scale up and you can say scale down your resources. Let's say you have deployed multiple resources to your containers, and you are lagging with some resources to your host machine, and you want to scale up some resources to your host machine. So how can it be possible with that? So that all sort of things can be done in this. So moving further, there are some queries regarding our container are recreated if they fail. So there might be some scenario like you face some issue with your container and it got failed by any such regions, and you don't want to stop those container. It should be up and running all the time. So how you can fulfill these requirements? So these are some queries that is been resolved in this Docker Swarm. So moving,
Excuse
yeah.
me. What do you mean by blue-green deploy?
Yeah, basically it's a, you can say it's a flag which give you can say blue indicate which is like your container is executed and it's still present in your machine, but it is not performing any task in it. So you might have came across with Nginx is just started, and you can say you have just pulled the image for Nginx, and you have just started those container, and later on you just stopped those containers. So that stage is nothing but the you can say blue deployment. Your actual deployment is already done, but it is not being used at that time.
Okay.
Yeah, and the green is like you are using that container in the real time scenario.
Okay. So it's up and running and it's performing tasks as well.
Yeah, so green is like it should be up and running and it should perform a task. Yeah. So
Thank you. Yeah.
yeah. So moving further, these are some queries which need to be resolved by some new feature of the Docker. So these have been taken out with the help of resolved with the help of Docker Swarm. So Swarm is basically is nothing but the it's you can say a cluster orientation, or you can say orchestration management tool which help us to build. It is one of the DevOps Docker's tools only. It is came along with the Docker itself. So it was launched in the 2016. So in that they have launched with some certain Swarm kit libraries. In that they have build up some sort of libraries to manage these such failures, like which we was already discussed in the previously, like our system should be up and running. There should be some scale up and scale down in this, and thereafter there are some commands of this Docker Swarm. So that is also included in your Docker latest versions. Like it should be available from the Docker version from 1.12. So in our case, we have already installed the latest version. So our Swarm mode will be already included in our Docker package. So you should be aware of you should enable your Docker Swarm services, because this requires some additional enabling services to be enabled before using this Docker Swarm mode. So there is some architecture how this Swarm works, and how this Swarm cluster can be deployed. So this is one of the cluster. You might have heard about some Elastic cluster, Elasticsearch clusters.
Yeah, like having several nodes, right?
Exactly. So similarly, it also has some several nodes and having some master and some workers as well. You might have came across with Hadoop clusters. Have you heard about Hadoop?
I haven't done Hadoop cluster, but we've done a three-node Elastic cluster research. Elasticsearch cluster, three-node cluster. We built it for the project, the Xenstack
Yeah,
project.
absolutely.
Yeah.
So way far similar to it. So this is also has some multiple node cluster. So there are some Docker Swarm master cluster, and there are some Docker Swarm worker clusters. So in the worker, we usually the name itself shows us that we are trying to allocate some works to those worker nodes. So that all sort of things we're gonna cover into our coming slides as well. So there you can see these are some clusters representations. So let me take up to some pointer here. So these are nothing but your list of So this is basically a Swarm cluster. Basically, this is managed by certain managers, and some bunch of workers are there. So in there might be multiple managers and multiple workers are there. So there are some different roles and responsibility of these managers and the worker machines. So these are nothing but these are the individual machines, you can say, individual host machines. So this is one host machine. This is another host machine, which might be stored in some other machine, you can say, or you can say other cloud as well. Similarly, this is also one another node, you can say, and they might be stored into a different distributed system. Like one node should be uh, having some into some different region, and another node is been stored into some different region. So they basically communicate with the via TLS. We call it TLS as transport layer security. So this is basically to provide the security between these manager roles, so that they can share those share those scheduler and what all sort of task is need to be performed with the worker. So all such things are being shared between these managers. So there is one, at least one leader should be there. So that you can say master of master is there. So in these three there might be some one of these leader of these masters, and the worker can communicate with each other by no stoppage as well. So if you have assigned some leader of the master, so that leader will be first mode of communication with the rest of the workers. So you can say if the leader is nothing but it will be the first mode of communication with the workers. So if you want to take up some task to build up some container and assign some images to it, so that has been managed by the worker. So in that, what basically manager will does lead manager will does, this will try to spin up these such requirements. Like we want to spin up the, let's say we want to take up some simple Docker Compose file, and in that we have allocated some certain container has been written in that, and some images have been attached to it, and some volumes have been provided to it. So what this lead manager will does, it will try to replicate uh, those YAML execution, or you can say those requirements, or you can say those tasks to different workers. So what in this case, your application is also stored in this worker 4 as well, worker 5 as well, and the worker 6 as well. So by any reason, if any of these worker get stopped by any network failure, your application should be up and running too with any of your adjacent workers. So in this way, they try to replicate your execution of your application. So in this way, your application will be up and running all the time without having any low latencies. So what?
I have a question. So the workers will be the nodes then?
Yeah, you can say
Okay.
node is nothing but the machine.
Machine, yeah.
Yeah. So all these are nothing but the machine. So these are individual machine, but I have assigned three of them, or you can say 3 to 4 of the machine as a master machines, and the rest of the machines are as my worker machine.
Okay.
So in that, I need to make some configuration to interact with master and worker. So worker should be defined into as they are the worker, and the master are should be initiated. There is one command to assign those master and initializing those Swarm cluster in the master machine. So we need to make some configuration so that they can realize that what are their roles. Like let's say I'm talking with the worker 6 machine, so he should know that he is a worker of this cluster. So there is one command, we call it as Docker Swarm init. So in this, basically, I need to put that command into the master machine, and later on, after the allocating the master, I need to allocate that worker machine, which is need to be fall into that master machine. So in the coming session, we will get into it as well. So how we can allocate the workers and how we can allocate the masters.
So each worker has one manager then for your diagram?
No. The diagram is like you can say it's a bi-directional diagram.
Okay.
So yeah, there might be multiple workers. So as I said, there is a one lead manager who is uh,
Mhm.
yeah who is managing all those workers. So
Okay.
if any tasks need to be allocated to your workers, so that manager is you can say is a single point of communication with those workers, and the rest of the manager will be playing as a stationary role, because they are nothing but they are backup managers. So in case like there might be some system failure with the manager as well. So this might be the possibilities, like your manager also get failed by any such issue. There should be some backup manager who can manage, or you can say who can take up that lead manager role, and who can make this process continuously, so that our cluster should not get stopped in between. So for that case only, these are the backup managers who are running in the backend as well. So there is only one manager who is running, or you can say who is taking the part in the execution process, and the rest two are nothing but they are just uh, uh, kept as a backup manager. So if your lead manager is been stopped by any such failures, so your backup manager should take over that roles and responsibility of that lead manager.
It is kind of orchestrated in such a way that there is no interruption in the task, but the task keeps going on without any hindrance.
Exactly, exactly.
And if any chance an issue arises, they are immediately resolved and the process keeps continuing smoothly.
Exactly. So let's say have an example like worker 5 and worker 6 and worker 4. So these four are your workers, and you have deployed one container into it. Yeah, and you have deployed one container of WordPress and Drupal, and you want that those containers should be up and running. So what this master will does, it will make it will make that container replication into different workers. So if in case your application container which was running in the container 6, this got stopped by any such failure, so exactly replicated container has been running to container 4 and the container 5 as well. So if your containers, or you can say if your machine 6 is stopped, and your container will be exactly on the same way, same situation, and the same scenario, your node 5 machine will be running the same container in that machine as well. So your data and your application process won't get stopped in between. So this is how it is get managed with that. Yeah. Yep, guys. Any queries still here? Understanding this?
No, and what's a certificate authority? Like they have the power to execute, give instructions to the workers. Is that what it means?
Yeah, and that basically they have some certain level of, this is only attached to the manager level, basically to communicate with each other in the form of like I'm the manager and I want to assign this role. So
Mm-hmm.
in this certificate only they are authenticated, like this is the instructions of the manager. So then and then only the worker will understand that this authority has been or you can say these are some tasks which is given by the manager. So in this
Okay.
way, the worker get understood with this.
So that it can be differentiated between worker and manager.
Exactly, exactly.
Okay.
Yeah. So TLS is already we have discussed that basically it is communicating between each other, like in the form of transport layer security. There is some layer which is need to be created above that. So in the deployment part, we can understood that the deep IT as well. So this is basically I've started taking up some wider picture of example, like you might have you might see here there are some certain managers are attached, and those managers are attached with some certain workers as well. So every manager are allocated with some certain workers here. So those workers are nothing but you can say.
Hello.
Hello.
Hello. Can you please repeat what you said?
Hello?
Hello, your voice is breaking.
Okay, am I clear now?
Hello, can you hear me?
Yeah, I can hear
Okay,
you.
yeah. Now it's better. Your voice is better. I can hear you now.
Okay, okay. So I was just telling that there are some workers which is assigned directly to the manager, but the roles and responsibilities you can say given to those worker by the lead manager only. So let's say you can see if the manager one is facing some issue, or you can say we have allocated this manager one as a uh, lead manager. Let's consider this as a lead manager. So this is our leader manager. So this is the only responsible for you can say to perform an execution into these such workers. So it has a control direct control to these such workers like worker one, worker two, and the worker three, and the rest. Sorry, worker three is not directly okay. So you can see the worker 5 is directly under the control of the master one machine.
Yeah.
So similarly, there are these managers had some own workers attached to these such managers. So if you perform these if you perform any task to the lead manager, and he has a direct control to these such workers. So what if when you want to deploy any such application, and you want to make some replication of those applications, because there should be any replication, because then only your cluster should be can say this is said to be an orchestrated cluster, because your application should be up and running all the time. So if you have allocated only one worker, or you can say only one worker, and you have not replicated your container to different workers, so what if that in that case your same worker will be your single point of failure. So if that worker fails, so your application will be stopped by full, or you can say by any reason such. So in that case, so your manager has some multiple workers attached to it. So in this, they usually try to replicate your similar container, like the similar sort of instructions has been deployed to another workers as well. So that have been done in the background only. So you don't need to directly go into each workers, and you don't need to replicate those instructions of YAML files. So that has been done by the manager instructions, and those have been allocated by the manager levels. So the priority is given to the managers, or you can say first communicated workers, like our lead manager worker 3 and the worker 6. So I'm taking,
Hello, sir.
yeah, hello.
Hello,
You
can you
cut off.
please repeat what you said? Your voice got cut off.
Okay, okay, okay. Let me, hello, hello.
Hello? Hello?
Yeah, now is it clear?
Yeah, it is clear now.
Okay. So I was just saying that your allocation of execution of the file, so by the manager. So, hello.
Hello?
Yeah.
Your voice got cut off.
Uh, uh, One sec. Let me my network.
Hello, sir. Hello.
Yeah, we can't hear him.
Oh, okay.
Hello.
Hello, can you hear
Yeah.
us?
Yes.
Atul?
Yes. Now
Yeah.
I'm audible. Yeah.
Yes, yes, you are.
So can you guys see my screen?
Yeah.
Okay. Let me now access. Yeah. So basically, this is a Swarm cluster. The workflow, how this Swarm cluster works. So basically, there are some managers are allocated. So there is a basic prerequisite to set up this Swarm cluster. You should have at least 3 managers because they have some requirement of at least having the initial level of 3 managers. You can take up to multiple 20 to 30 managers as well, but that is not at present. We have not came across with that much big application. You need these much managers as well. So these 3 managers are enough, very enough. You can say.
Hello.
Yes, guys, can you listen me? Yes.
I can hear you now.
Okay, great.
So you just
Okay.
mentioned that there is a prerequisite to have at least 3 managers. Is there any limitation on the number of workers they can manage?
Yeah. So as I said, in the worker, you can have at least one worker to a single manager, but there should be at least one worker attached to your manager, and you can have multiple worker. So there is no limitation of uh, of at least 3 workers to your manager, and overall you can have multiple worker like hundreds or 200s of machine, any count of machine, but your single manager should have at least one worker should be attached to your that manager, or you can
Mhm.
say to any of those managers. Let's say in my case I'm taking these 3 as a managers, and in this every manager should have at least one worker.
Okay.
So he or she can directly communicate with that, or you can say he taken some roles and tasks to get assigned to those workers. And but to set up the manager, you should have at least three managers should be there.
And in your case, when if the one manager is assigned to 3 workers, uh, so among the workers, is there any differentiation? Are all the same?
Yeah, they all the same. Basically, in the lower part, at the worker level, they communicate between each other, but
So
the
if
instructions are given by the managers only.
okay.
Yeah. So in the lower level, the worker level, they communicate with each other. So you can say there is one network above that. It's a gossip network. So in this, basically, they communicate with each other like what task is assigned to you. So similar tasks should be done by me by these workers as well. So they both communicate with each other. Like worker one will communicate with the worker two. So
Okay.
to perform the similar task into other worker machines as well.
So when they communicate, they'll automatically generate replicas of the task, the container or application, so that
Yes.
they can serve as a backup in times of need.
Yeah, so in the background only, the same part of execution is already being done with your as per your YAML, you can say file
Okay.
config. Yeah.
Okay.
So moving further, you can say there is one scenario. If that scenario comes into picture, like you have some more than 3 or 4 manager are in there, and you want some manager to pull out from his role and want to allocate those manager to a worker, that too you can do it. So there is one pull out responsibilities is also assigned, but you should manage that. You can say you should fulfill that prerequisite. You should have at least 3 managers, and if you have fulfilled those requirements, and later on you have multiple managers, you want to pull out those managers into some worker machine, that too you can do. But it is not done in the vice versa. Like your workers can't be taken as a manager, but your manager can be pulled out and can be assigned to a worker. Yep, guys, are you there with me?
Yeah.
Okay. So moving further, how these sort of instructions have been given from the worker manager to the sorry from the master manager to the worker manager. So there are some rafting techniques are used. Like there are some APIs are created in the master manager, or you can say master node. So these, as I said, these are nothing but these are the individual machines in the form of, we call it as nodes. One node, two node, and 3 nodes are given to manager as well. So in similar way, every node has some sort of uh, some instruction which is need to be performed, so that then and then only our worker node get all sort of execution list. So what it should execute into this worker. So basically, the service create is basically starters to create the services like uh, this Docker service create. This help us to start the uh, swarm clusters, you can say, to initialize that service. We call it as swarm. Let me take up that command. So basically, Docker swarm is basically provided to your to assigning the master of your swarm. In this, you will see here these are some commands of this. So in the coming session, we'll get more handier to these such commands, how we allocate the master machine, and how we allocate the worker machine, and how we bind those worker to the master machine. So with the help of Docker node, you can list down the list of the nodes which is falling under to this master machine or any of this total worker machine. So with the help of Docker node ls command, you can list down all those list of machines which is attached to it. Similarly, Docker service is basically to start the services which you have created for your worker machine. Those have been created from your master machine. And similarly, there are some stacks as well. So that all sort of command will get some more handier to it. So there are some secrets as well. So to make some authentication between each other. So they share some secret keys as well. So guys, am I audible now? Everybody?
Yes.
Okay. I was here to how we make some set of instruction and how we allocate those instruction to the worker machine. So there are some sort of APIs is provided by the you can say the client as well. So that will try to accept all such requirements from the users. So then later on they make some orchestration loops like how many machines should be allocated for this task, like how many loops should be created for these containers, like it should be have some 2 to 3 machine loops. So then if any one machine get stopped, so it should has. So this is basically a theoretical part. So in the actual deployment we don't need to get into deep this. So all these things are managed by the Docker manager on the libraries which is already executing in the manager machine. So that are the parts which is executed by the manager machine, or you can say manager nodes. And then later on the scheduler part is nothing but they assign the task which is need to be performed on the worker node. So these are some list of instruction which is need to be executed on the worker node. And the dispatcher is nothing but this will dispatch your task, but it will first check the worker, that worker is present in that location or not. So there might be some scenario like your worker is not existing in that directory, or you can say it is not available right now at the moment. So in this case it will try to dispatch it into some different workers. So this is how the role of the manager node get complete, and later on those tasks have been assigned to the worker. And just
What
after the execution, yeah.
what is RAF?
Basically, raft is a technique which is followed like you can say following starting from the API. They have given this such a small name for this. So I'm not but familiar to this terminology, but they given this techniques and this methodology as a raft methodology. So you can see this is they're also they have provided this raft consensus groups. So in that they basically follow this raft technique to perform those master, or you can say manager level of instructions. So this is basically the part of terminology. We can clear it out with performing you can say deploying this actual cluster while our machines get up and running. So in the coming session, I will spin up some certain machines in the form like I will take up some at least 5 to 8 machines, and in that way we're gonna deploy these such small cluster of this swarm. So usually in the corporate they have huge clusters, they have a huge number of worker machine, and with those they are always up and running. Their application is always up and running because they are using multiple workers and multiple replication have been created. So if there one application machine got destroyed, or you can say got stopped, so they have every time a backup is ready with them. So in this way your uh, latency is very less in the you can say uh, the thing which you have done in earlier. We have tried to spin up the container in the host machine. So here host machine was a single point of failure. So if your host machine got damaged, your whole container and your whole Docker compose file, or you can say everything got destroyed here. So to stop these such scenario, they have tried to allocate multiple machine which has been stored into remote locations. So there might be some of the machines stored in the Virginia region. There might be some machines stored in the Ohio region. So in similar way, your machines are stored in the distributed location, and you have set up these swarm clusters. So in this way, your full-fledged orchestration is working with the help of Docker Swarm. Yep, guys. Any queries here? So later on, we can see the worker node has executed all those scheduler tasks which is provided by the manager, and it gives some acknowledgement to the manager again that he has performed all these tasks and without any failures. So that the manager get understood that the all the tasks has been stored and it's been working to this worker because of this worker's machine.
So the
So
manager will also resolve issues faced by the workers when they are performing a task.
no, it will only make some allocation only. So if the worker one is not capable of doing those, it will assign the task to some other workers.
Hello?
Yeah, hello.
Sorry, I couldn't hear you. What did you say?
So I said that basically the manager doesn't resolve any of the tasks and it doesn't perform any of the tasks, but it will only verify that the task has been performed to the worker. So if that the task is not performed properly with that specific worker, so it will pull out that the task from this worker and it will allocate to some other worker to perform
Oh,
this. Yeah, it will
okay.
not resolve it manually. It will allocate to some different. So it will does all sort of manager level roles.
Okay.
Yeah. So there you can see I've taken some simple example in similar way. So there you can see there are some workers are there in the form of Tableau and I've allocated some master and I've taken one master as a lead master, which is acting as a lead manager as well. So this is basically the communication. The very first communication has been done, or you can say whenever you hit up any of the execution command to deploy any of your compose file, so that has been given to this master level machine, and it will try to gather all sort of instruction. It will try to gather all these instructions, and based on this, it will pull those instructions to the, or you can say it will schedule those instructions to the workers, and the very first execution is been done with its own worker, and later on you can see these worker are individually connected with their own network. So if the first thing will be shared with this worker and later on it can be shared with these different workers as well. So he or she, this manager can't directly you can say hit to this workers. The worker automatically they share their sets of instruction between these workers, like manager has allocated, like we want to have three level of replications, or you can say five level of replication. So in this, the role of worker came into the picture. The worker will assign to how much machine should, or you can say to which machine should get this replication factor satisfied. So the worker fulfill all this requirement of the managers. Yep, guys.
And what is the manager quorum? That is, you should have three managers at least. Is that what it means?
Yeah, absolutely. Because there is a, you can say prerequisite. We all said that they should have at least two backup manager for that. So
Okay.
quadron is basically, yeah. So
And worker gossip means just communication between the workers.
exactly.
Okay.
So if manager has given some replication factor of three, or you can say four, so the worker should gossip between each other in the form of like it should fulfill the requirement of the manager, because manager will not individually go to the each worker and it will not allocate the same task to different workers. It will allocate only to his workers, and his worker will be communicate to the rest of the workers to fulfill the requirement of the managers. So this is the workflow how the swarm clusters work. So manager will directly communicate with its own worker, and later on the worker gossip can say they share uh, those compose file and they fulfill all those requirement of the managers.
Mm-hmm.
Yeah. So in the coming session, we're gonna deploy this simple machine to the managers as well, and we're gonna take up some workers machine, and we're gonna assign some lead manager in it, and we're gonna deploy some small compose file to it to fulfill our requirement in the form of replication, and we're gonna manually will try to destroy these such some simple master machine, and we'll check how our allocation of the master are been done to different master machines. So this is very much automated part. So in this way, your container running should not be get stopped. Should not get stopped. So this is how this is why this concept came to fulfill all your requirement for most of the time. So the Docker Swarm cluster basically fulfill all this need of having your application should be up and running all the time without having any failure to it. So this is the same thing which you have already done, basically to accept, store. So basically API and orchestration is nothing but this will try to accept the queries of the client, or you can say the one which we give it to the Docker client command, you can say client terminal, and then that it will try to accept and store it and orchestrate the how this code should be orchestrated to the worker machine. So those are being allocated to the orchestrator, and the reconcile basically to whom to schedule these tasks. So the very first thing is it will try to prioritize to his own worker also, and if its own worker is not available, so then thereafter it will communicate to the uh, other master machines worker. So it will first prioritize to its own worker, and thereafter it will allocate to its adjacent customers. There you can say, let's say we have a simple example like this is one of our Swarm manager. So in this, we want to deploy our Nginx service. So we want to deploy one Nginx service with having some replication factor. Is this? Oops. Yeah, there you can see we have requirement of at least installing Nginx machine into having at least 3 replication into our worker machine, and this is how the master is allocating the application of your Nginx and two different machines. Like this is your worker machine and this is your master machine. So this is the available node. So as per the availability, it will try to allocate the task and the container which is attached with some images as well. So Docker images we call it as. So thereafter your task gets fulfilled, and those they will acknowledge the manager again that we have properly executed the task, and the manager will get some acknowledgement that your application is running to these such different workers. Like your worker one gets stopped, so manager will pull out your deployment from the worker one, and it will attach to the worker two automatically. So your application should not get some low latency. Like your application should not get stopped responding anything from it. So in that very short span of time, your uh, your your manager is quick faster to allocate your deployment part of your Nginx server or Nginx applications. So in this way, we usually perform the task in the such uh, Swarm clusters. So the master are allocated with some certain instructions of deployment of your application. Like in our case, we are taking Nginx application to be deployed into those worker machines. So this is how they basically communicate with each other and they fulfill those requirements from it.
So here in this in this diagram, the manager is having all the replicas and it's allotting one replica to each of the nodes.
No. These are the instructions given to the manager by the users. So like user want to install the Nginx, so manager will set up some replicas to it, and it will assign those application having some replication factor. Like we have set up 3 replication factor. So these are the rest of the worker machine. So
Okay.
yeah, every worker machine is attached with the
Image.
file, and the container is running to that worker machine.
Okay.
Yeah. So in this way, like it is fulfilling to 3 different machines. So these are the 3 different machines. So you can visualize. In our case, we have deployed more than 5 to 6 container into one machine. So we are the thing which we are doing in the previous year. Like we are having only one host machine, and above that we have installed the Docker package, and above that we were trying to we have usually spinned up to you can say have 8 to 10 containers I've spinned up with my host machine itself. So you can imagine that in similar way, you wanna assign some other task, or you can say you wanna make some WordPress application, and you wanna make some replication of it. So your this host machine, or you can say this worker machine, it is capable of having multiple tasks running into these machines as well. So it's nothing but the, you can say it's an individual host machine in our example, like the thing which which we were doing till now. So this is one host machine, this is two host machine, this is three. So every host machine is capable of running multiple, more than 5 to 10 containers at least, as per their specification and resources. Yep, guys. Any queries still here?
No.
Okay. So this is just a simple example of deploying the Nginx to different worker machines. So there are some full okay, so full heavyweight with page deployment. In that case, you might take up you might consider some front end level of application containers, some back end, and some libraries managing container, and there should be some database container should be there. So in this case, you want to merge up these 4 to 5 containers for your single application deployment. So all these 4 containers will be running into each worker machine. You can imagine how we are dealing with. So in this case, if your any of your worker machine got stopped by any such failures, so your application should be up and running all the time. It should not face any issue in the form of not responding and all. So it should has at least uh, 3 replication factor, so that your application has 3 copies of execution. So here we are dealing with a simple example of Nginx. So this is only one container. So I was just taking as example of having 2 to 3 containers of your full-fledged project. So this was the case I just wanted to take up. So in the coming session, we'll gonna set up this clusters, and we're gonna spin up some simple small scale project deployment to it. Yep, guys, are you there with me?
Yes.
Okay. So I would say I would rest my words here, and any queries, any questions, please to ask me here.
That's about it. So the workers, they carry multiple tasks at the same time. Each worker, like there are multiple um, operations being executed by the workers at the same time.
Yeah, they are capable of handling multiple container running at the same.
Containers.
Yeah.
Okay. And if one worker fails, then its task is passed on to the other 2 workers in the swarm of the 3-node cluster of Nginx that you showed us.
Yeah. So as I said, there was a requirement given by the client, like
Okay.
his project should be having at least 3 replications. So what if my 2 of the worker is running properly and one of the worker got failed by any such reason? So that worker performance and that worker task will be allocated to the another you can say the adjacent worker itself. So it should fulfill that requirement of the 3 level of replication factor.
And if one of the manager fails, how does Docker take care of it?
So if
Does
the
it
manager
bring in a substitute manager somewhere, something like that?
no, so as I said, there is only one manager who is acting as a lead manager.
Yeah.
So yeah, so this is, let's say we have taken this manager as a lead manager. This got failed by any such reason. So by any of these from any of these 2 manager which is left around, like
Okay.
manager 1 and manager 2, this from this any of these one will be considered as the lead manager again. So
Okay.
Yeah, so if this later on this manager is up and running, so this will be assigned as the uh, adjacent manager, you can say. This will not again assign as a lead manager. Till
Okay.
then, if the previous manager gets some failure to it.
Okay.
Yeah. Yep, guys, any more queries?
No.
Okay, guys, we can wind up our session here. So, guys who are facing some issues, you can stay here so that we can resolve it again.